Welcome to Big Data Flex. Today we are going to learn about a Spark. In this lecture, we'll be covering why Spark, what is Spark, and a Spark architecture. So before going to learn about a Spark, let us see why do we need a Spark. I hope you have knowledge about big data. If you don't have knowledge about big data and wanted to know more about it, kindly go for big data tutorial. In big data world, Hadoop is the most famous ecosystem. Hadoop provides two things. First, how to store big data, which is known as HDFS, and how to process big data, which is known as MapReduce. MapReduce has done commendable job in solving big data challenges, though it has its own limitation that people faced in different situations. Now let us see MapReduce limitations and how Spark addresses them. First of all, there is no support for language other than Java. Java is the only supported language in MapReduce. One has to write so much Java code to implement any logic. People wanted to use other language like Scala, Python, in which they were comfortable. So Spark resolved this limitation by making API available in various languages like R, Scala, Python, Java, and SQL. It is flexible enough to support any other language in future. Another problem with MapReduce is related with performance. MapReduce jobs are slow. The reason for this is that it always reads input from disk and writes output to disk. Spark provided a way to store the result in memory that makes it very fast. It is 100 times faster than MapReduce for in-memory input and 10 times faster for data when that is on disk. Inefficient for interactive algorithm is the next limitation of MapReduce. People sometimes wanted to run their algorithm repeatedly on a set of data. In MapReduce, it is not possible because of performance overhead. The kind of iterative algorithm is required to train models. Spark handles this by providing a way to define and save the working set of data in memory. The next problem with MapReduce is that it is not interactive. MapReduce does not give result in less time and hence not suitable for interactive processing, where user expect a result in less time to verify the data or algorithm. MapReduce does not have any support for streaming analytics. There is no way in which we can analyze the real-time data. It is always batch analytics. But there are situations where we wanted to analyze data as we consume. For example, a trading company wanted to come up with trading strategy as per the market sentiments in near real-time basis. In MapReduce job, the company has to wait significant amount of time, maybe one day, to know the sentiment. Spark made it possible to analyze streaming data. It has dedicated module to handle these stream of data, which is known as a Spark streaming. The next problem in MapReduce is a pipeline of mapper or reducer. In MapReduce, every problem is solved by providing mapper or reducer. So given a complex algorithm, we end up designing multiple mapper or reducer. In this setup, output of one stage of mapper reducer becomes input for next stage. It's difficult and cumbersome to represent algorithm in the pipeline of mapper and reducer. Spark provides a way to cleanly define the processing and executes them in cluster elegantly. So what community wanted? Community wanted a system to develop sophisticated algorithm by combining power of batch, interactive and stream processing. They also wanted a system which is compatible with Hadoop ecosystem. Keeping above requirements, multiple solutions were developed and we ended up having them as separate component in Hadoop ecosystem, like Impala for in-memory, Storm for streaming, Hive for SQL, Gyra for graph processing. These systems are specialized to solve special problems, but not all the challenges of MapReduce. During that time, Spark came as comprehensive solution. A survey did by Apache related to Spark, and it found that 91% use Apache Spark because of its performance gains, 77% use Apache Spark as it is easy to use, 71% use Apache Spark due to the ease of deployment, 64% use Apache Spark to leverage advanced analytics, 52% found Spark good for real-time streaming. So all these statistics tells us about what is a Spark. A Spark is fast, easy to use or deploy, general purpose cluster computing framework. Spark extended MapReduce and supports other technique of processing like streaming, interactive. Let us see some of the features of a Spark. Some of them we have already covered and some of them we can see here. Like in-memory computation we have already covered. Because of this, Spark is fast. In Spark we can execute programs in its own cluster or use other cluster resources like Yarn, Mesos. Spark can process data stored in various other storage systems like HDFS, HBase, Cassandra, Hive. Spark is compatible with existing ecosystem. In Spark, it is easy to combine batch, streaming and interactive computations. Now let us see Spark architecture and how is it coexisting in Hadoop ecosystem. At the center of a Spark, we have a Spark core, which is heart of the Spark. It contains basic functionality of a Spark. It has component for task scheduling. It has memory management module, which is also responsible for in-memory storage of intermediate data. It has API in Java, Python, R. It defines RDD, which is resilient data distribution. On top of core, we have other libraries like Spark SQL, which is packaged for working with the structured data. Spark SQL allows a structured query language and Hive query language. It supports many sources of data including Hive tables, JSON. It allows developers to intermix straight SQL with other programming constructs. So in a program, you can have Spark SQL queries as well as a Scala programming construct for manipulation of data. The next important module in Spark is Spark Streaming. As we have already seen that it is one of the major features of Spark. This library enables us to process live streams of data. We'll see more about this in our coming videos. The next important module in Spark is Machine Library. It has optimized implementation of machine learning algorithms including classification, regression, clustering, and collaborative filtering. People can use this library to build their models. The next important module in Apache Spark is Graphics, which supports manipulation of graphs. Then comes the cluster management. Spark supports various cluster managers like Hadoop Yarn, Mesos, Standalone. The last layer talks about the various storage systems where Spark can interact and read data for processing. So this is all about Apache Spark